Hi, and welcome to Big Data and Strata apartment buildings. There are 320,000 multi-tenant buildings with 2.6 million individual apartments in Australia. These apartment buildings are consuming over $2.7 billion on electricity, and by 2050, 75% of Australia's population will live in apartments. There is an energy efficiency opportunity of 45% in the strata common areas. Solar has less than 1% penetration into strata. Electric vehicle charging has less than 1% penetration in strata. And heat pumps are becoming the most common method for heating pools in strata buildings, but have less than 0.03% penetration for heating the common hot water plants. Here's some benchmark data collected on strata apartment buildings with services. Only 5% have full air conditioning. 65% have mechanically ventilated car parks. 33% have a heated pool. 32% have a gym. And interestingly, 4% have domestic hot water provided as a service by strata and paid through strata levies. We're going to look at the energy consumption in strata common areas. The first graph here basically shows us that high-rise buildings have more facilities in them that consume energy than medium-rise or low-rise. In this graph, we're looking at the average common area electricity, gas, and water costs by high-rise or medium-rise or low-rise buildings. And the results here are pretty much as we would expect. High-rise buildings have the highest electricity costs compared with the other building types. In this graph, we're looking at the average common area electricity spend in total, but across buildings where the building types have lifts in them. Now, all high-rise buildings have lifts in them, where most medium-rise have lifts and only a few low-rise have lifts. But as you can see, lifts do contribute to increasing the electricity spend of buildings which have them. Again, in this graph, we're looking at the total common area electricity spend in buildings by different building type, low-rise, medium-rise, and high-rise, where they have centralized air conditioning plants. You can see that as you move into high-rise buildings, the cost of that air conditioning starts to be a driver of the total common area electricity cost. In this graph, we're looking at the effect of having a secure car park, which typically has car park ventilation. And as you move across the different types of buildings, the cost of running a secure car park can also have an effect on increasing the total common area electricity spend on average. Here we're looking across different building types, again, townhouse or villa, low rise, medium rise, and high rise. And we're looking at how having an unheated pool drives the total costs of the common areas. In this graph, we're looking at the average common area electricity spend by building type and seeing what impact the gym has on the total common area electricity. And it really isn't as large an impact as people would think. So in this graph, we're looking at the proportion of total common area electricity spend by facilities such as lift, ducted air conditioning system, gym, unheated pool or heated pool, and the building type. And as you would expect, the high-rise buildings have greater costs than their medium-rise and low-rise companions. Now we're going to have a look at energy efficiency recommendations. The most common energy-saving recommendations for low-rise buildings are solar installation, and that's followed by LED lighting upgrades. If we move to medium-rise buildings, we can see that LED lighting upgrades becomes the most common recommendation, and that can be moving from first-generation LED lighting to second-generation motion-censored LED lighting upgrades. If we look at the most common recommendations for high-rise buildings, again, we would start with LED lighting, followed by solar, followed by hot water upgrade. Now, in this table, we're looking at the top performers in the common areas of the building on a per lot basis across the building types of high rise, medium rise, and low rise, and then comparing the difference between the top performing buildings in each of these categories on a per lot basis in the common areas against the average. So the top performers in the high-rise segment might spend $452 in electricity and gas costs in the common areas on a per lot basis per annum, versus 1,169 in the average across the data set. As you can see, as you move into low-rise buildings, there's actually a greater difference between the high performers and the average. In this section, we're going to look at solar, batteries, and electric vehicles. Here are some of the average installed solar PV in kilowatt hour sizes by building type. As you can see, low-rise buildings often have better roof space and can have just as large solar systems or even larger solar systems than medium rise. We would expect high-rise buildings to not always have large solar systems if they're a fairly small footprint high-rise in the CBD, but there are high-rise buildings now in Sydney that have up to 176 kilowatts of solar on them. In this graph, we're looking at the average solar PV potential by building type, and we have also cross-referenced the estimated savings from that potential solar PV system that could be put on the building. As you can see, the savings level out as you move into high-rise buildings, and you have a much greater cost of install, particularly if you have to crane the solar system to the roof and have extra expense around safety while installing the solar systems. Here we're looking at the average solar PV potential, the cost of the system in dollars by building type. As you can see, we've cross-referenced the simple payback period. The larger the size of the solar system, the payback is better, but the cost of install is higher. Here we are looking at the average battery potential, the cost of the solar battery system by building type, and we can see that the high-rise buildings have potential for higher savings from introducing batteries. In this graph, we're looking at the average battery potential payback by building type, and as you can see, the cost of installing a battery system for a high-rise building jacks up a lot faster. This graph illustrates that adding the cost of a battery into a solar battery system is much more expensive and also increases the payback. In this graph, we're just looking across some responses to electric vehicle surveys by building type, and you can see that more people that live in high-rise buildings are more likely to respond to a survey on when they're considering purchasing an electric vehicle. Some other survey results regarding electric vehicle charging in strata buildings show that 79% of people favour a user pays charging system, and 78% of people are in favour of installing charging systems right now. Here we can see, once again, if we look at the question of people being in favour of installing charging stations right now, it's slightly higher in the high-rise buildings than the medium-rise or the low-rise buildings. In this section, we'll have a look at energy retailers and strata managers, which are servicing the apartment buildings that are in this data set that we've analysed. We can see that Energy Australia has the largest number of participant strata buildings, followed by Origin Energy. If we look at the electricity retailers of the participant buildings in this data set by building type, many of the strata buildings are with Energy Australia, but there's a slight tendency to move towards Origin Energy in the high-rise apartment buildings. These box plots show the range of electricity prices with the top three energy retailers and the other energy retailers in aggregate. And this is for high-rise buildings. And so a high-rise building can look at this graph and see whether they fall within the range. Here is the same box plot, which shows the range of the energy costs for mid-rise buildings across the three top energy retailers and the others in aggregate. And here is a box plot of the low-rise buildings by energy retailer, showing the range of different energy costs for each of the three top energy retailers and all of the others in aggregate. Here is some data on the strata managers, which are represented in the participating buildings in this data set by building type. And if we just look at the top 10 most common strata managers in the data set which we analysed by building type, you can see here the breakdown of the portfolios by those top 10 strata managers across low rise, medium rise, and high rise. However, this just happens to be based on the sample set of data which were used in this analysis. In this graph, you can see what we need to do to future-proof the strata buildings in Australia for the future. So over time, all 360,000 strata buildings in Australia should start to become more like this diagram, embracing these technologies that you can see. So I hope you've enjoyed big data and strata apartment buildings. Thank you.